Hey guys, we're going to look at some box plots today. So right here is a little example of what a box plot would be looking like. Hopefully you guys have seen this before. I feel like you guys possibly could have. So a couple different things that we can look at is basically this is a way for us to look at data and make a summary about it. So there's a couple different things we can look at is our max. We just talked about our mean, median, mode, and range, and some of those things are in this box plot. So we have our max. That is saying that is our largest number, and our minimum is our smallest number. If you guys remember, that is talking about the range of numbers, so our smallest to our biggest. The other one we're looking at is our median. What number falls directly in the middle? And lastly, we have these 2 points, which you're going to be learning a little bit about today. So basically a box, and sometimes called box and whisker plots. Your box is mainly most of the data that's going to be contained in here. And then out here is going to be more so numbers that are farther away from the median or mean. Maybe some outliers can fall out here. So we're going to do one example together. So here I have some data points of you guys, how many minutes you guys have been spending on IXL. So I basically just pulled this many students' numbers and kind of wrote them down. And if you guys remember, the first thing when you're looking at data is you need to put them in order from least to greatest. So that's what I'm going to do right now. And as I write them, I like to cross them off, just to make sure I'm not making any mistakes with that. So 20, 38, there's 2 38s. So if you guys remember, if there's however many, whichever number occurs the most often, that is our mode. 38, 45, 51, 64, 67, 70, and 135. So always count on the end to make sure that you wrote down all the numbers. So I have 1, 2, 3, 4, 5, 10 numbers up there, 1, 2, 3, 10 numbers down there. So first, let's look at our range of numbers. So your minimum, maximum is just your smallest and largest number. So my minimum is going to be 9. My maximum is going to be 135. And if you remember how to find the median, just start from the outside and work your way in to see which number falls directly in the middle. And this one is a special one because technically there's nothing here in the middle of these two numbers. There's not a number that falls directly in the middle of the data. So we have to kind of guess what kind of number is going to fall directly between 45 or 51. So if you can see it, that's great. If not, find the mean or average of them. The way you can do that is by adding them up and dividing by how many numbers I just added up, which would be 2. So 45 plus 51 is 96, and then we just got to divide that by 2. 2 goes into 9 3 times. 4 times, which is 8. And 2 goes into 16 8 times. So our number directly in the middle is 48. So if you look at that, you can see that 48 is 3 away from 45. 48 is also 3 away from 51. So that is our median of 48. So this median is cutting my data in half. So we have quadrant 1 and quadrant 3. So those are going to be the ends of my boxes. So basically we're finding the median of 2 sides here. So we found our median here, so we split our data in half. So now let's find our median for the left side. So starting from the outside, working your way in, 38 falls directly in the middle. So that's my quadrant 1, which is also called the lower quartile, or yep, quadrant 1. And same for here, from splitting the data in half. See which one's directly in the middle, and we're getting 67 directly in the middle. So that's our quadrant 3. So these points are all you need to draw your box plot. So I have a line down here. You could draw any kind of number line you would like. I am going to kind of be rounding. I'm looking that I have to fit 9 on this number line, and also 135. So you could kind of choose how you would like to number your number line. I'm going to number them by, let's go with 20s. So I'm going to start out with 0 and count by 20s. 0, 20, 40. You want to try and make sure you have equal amount of space between them. Since it's 20 each time, it should be consistent. And I'm probably going to stop there at 200. So you can start and stop at any number, but as long as you are able to put these numbers on the number line, that will work. So we will have to kind of estimate where some of these numbers are falling since we did count by 20s. So let's start by putting our dots at our minimum and our maximum. So my minimum is 9. 9 would be very close to halfway to 20. So I would say about right there would be my minimum. And my maximum is 135. So if I have 140 right here, half of it would be 130. So I would say about right here would be 135. If you're close, that's fine. Doesn't have to be perfect. You know that we do have human error when we're doing it on pencil and paper. So we have our minimum and maximum done. Next, we have our median, which is 48. I like to draw a line. So 48 is very close to 50. So I'm assuming probably halfway between 40 and 60 is my median. Quadrant 1 at 38. 38 is very close to 40, so I'm going to put it about right here. And quadrant 3 is 67. Very close to halfway, I would estimate about right here. So once you got your 5 points on here, we can just kind of finish the graph by joining the lines, making a box, and then drawing our box out to our min and max. And this is your box plot. And if you notice, if you are reading this, you're going to have most of your data points falling between 38 and 67. If you guys look at our data, 38 to 67, that is most of our data right here that's falling within our box. That's where we're kind of making a summary about our data here. And you can see how far out this number is, our max of 135. That's called an outlier. So it's going to be a lot farther away from the rest of our data because it is much larger than the rest of the data.